In the video about nuclear radiation, you learned about alpha particles, beta particles, and gamma particles. Real quick, I want to show you what those look like. So on here, an alpha particle is going to have a mass of 4, and then we're going to write that on top. And it's going to have an atomic number of 2, and it looks like this right here, a 4-2 helium atom. A beta has a mass of 0, a -1 at the bottom, and then we use the letter E for that one. This is beta emission. Beta capture is going to use what's called a positron, and that's just a positive electron. And it's going to look like that. And then gamma is going to be 0, 0, because we learned that gamma is just pure energy. It has no mass or atomic number. And that's what the particles are going to look like. The way you do this worksheet, just like you saw in the video, we treat our arrow like an equal sign. 3 is equal to what number plus 0? We're going to make that a 3 on top. On the bottom, it's the same thing. The arrow is like an equal sign. 1 is equal to what number plus -1? If we put a 2 here, then that's going to satisfy that equation. The way I figure out my symbol is if I know the atomic number 2, I come over here and find helium as my atom. That is how you solve that problem. But now we need to decide what type of reaction this is. So name the reaction. The way you do that is you look through your equation and you try and find one of these 4 particles. Now on our first equation, we didn't have an alpha. We had a 3, 2, but it's not quite an alpha. But we did have this guy right here, 0, -1, E. That matches beta. Therefore, I know this is a beta emission. And it's beta emission because we're releasing an electron. Next problem we have, 232 is equal to 228 plus 4. That'll satisfy that equation. And the next one is also an easy one. 92 is equal to 90 plus 2. Do the same thing we did before to find out what that atom is. If you don't remember, 2 is He. That satisfies the first part of balancing. And then we have to decide, is it alpha, beta, or gamma? And right here we have an alpha particle, making this an alpha decay. Now I want to work one of the ones in the back. We're going to start with 12A. Write a balanced nuclear equation for each decay process indicated. The isotope thorium-234 decays by an alpha emission. The way we're going to start this is write our left side. So TH, and 234 represents the mass. If you remember, mass goes on top. And the way we figure out the bottom number is you go find thorium on here, and TH is right down at the bottom at 90. We're going to write 90 just like that. And it says the isotope thorium-234 decays. We're going to represent that with an arrow by an alpha emission. If we flip back to the front page, alpha emission was 4,2 He. Therefore, we're going to write an alpha particle, 4,2 He. Then all you have to do is satisfy the rest of the equation. 234 is equal to 4 plus 230. And then the last one, 90, is equal to 2 plus 88, just like that. And then to find out your element, go find 88 on the periodic table, and that is Ra. Work one more with you. Isotope Fe59 decays by a beta emission. Fe is iron. We're going to write Fe just like that. 59 is the mass number. That goes at the top. And then at the bottom, Fe is 26. And it says it decays by a beta emission. If we don't remember beta, we go back and look. Beta emission is 0, -1 E. We'll write that 0, -1 E plus 59 is equal to 0 plus 59. 26 is equal to -1 plus 27. And then we go find 27 on the periodic table, and that is going to be CO cobalt. That's all there is to it.